All right, let's get started with the interference worksheet. The interference worksheet has on the front it has 3 columns. Each column has 2 wave pulses that are coming at each other. Let me go through and show you what I think these look like right now. So the first one has a short wave pulse. It's too high. It's moving to the right, and it's separated by basically 4 spaces to one that's 3 high. They have the same width. So this one's moving to the right, this one's moving to the left, and it says that they move 2 spaces each every 1 second. So 1 second later, this one has moved 2 spaces this way, and this one's moved 2 spaces this way. So the thing about this is, there's only one piece of string. And so they've moved so they're really close to one another. In fact, they're next to each other. So that's what they look like. Now, the next one is the interesting one because now they're, in essence, right on top of one another. But what we know about waves is that they add. So this one is 2 high, and this one is 3 high, so the total is 5 high. The next thing we know about waves is that they pass through each other. So in the next moment, this 3 high is going to be on the far side now. So that one's 3 high. It's next to one that's 2 high. And then after that, they have passed through each other. So there's the 3 high. There's the 2 high. Well, it was a little short, sorry. And this one is still moving to the right, and this one is still moving to the left. So that's the interference pattern for that one. Let's do the next one. The next one we have a similar situation, but we have the 2 high moving toward the 3 high, but now it's 3 high, but it's down, which is interesting. So again, they're moving toward one another. So this is still 2 high, but now this is 3 high and down. And this time when they're right on top of one another, since this is 3 down and this is 2 up, we end up with a situation where it's just 1 down. And again, waves pass through each other. So after that, we're going to have 3 down, 2 up, and then finally 3 down, 2 up, and here they're moving at one another. This one's moving right, this one's moving left, and this one is still moving right, and this one is still moving left. All right, let's reset. Let's do the third one. So this one's a little bit different because we have a 2 high coming at a 3 high, which is totally fine. So I'm going to get rid of this too. So I have my 2 high here, moving toward a 3 high, which is over here. But what you're going to notice is that the width of this one is a little bit shorter. So this is moving to the right, this one's moving to the left. After a moment, this one has moved 2 spaces to the right. This one has moved 2 spaces to the left. And what happens when they're right on top of one another? Well, they add in the places that the waves overlap. So in this first section here, there's no overlap because this one is wider than this one. But then the overlap is here, so it's 3 more tall. It's called constructive interference when they add together. And then we know that the waves pass right through each other. and then finally. Now, obviously, this is within my ability to draw this, but I think you get the gist there. And this one's still moving left, and this one's still moving right. All right, that's the front. Let's look at the back. The back has two principles on it. The back has a not only what happens when the waves overlap, but it also what happens when the waves hit some boundaries. So let me sketch up the first one here. Okay, let me sketch up the first one here. What we're going to have is we're going to have a wave. So it's two wave pulses that are following one another. So it's a square looking wave here. And it's trailing right behind a triangular looking wave here. And what these dudes are doing is they are traveling toward a fixed boundary. Now, two things we know. One, if the wave hits a fixed boundary, it is going to reflect, but the thing about that reflection is it's going to flip over and then reflect as long as the boundary is fixed. So in the next view of this, everything is moved forward. This one's here. This one's here. It's just reaching the boundary. Now, in the next section, because we're moving 4 spaces every time, this point here has moved 4 spaces. This point here has hit and moved back 4 spaces. This has moved 2 spaces this way, hit and moved 2 spaces back, which means that this one here is going to be directly on top of this one, but this one flips over. And so what we end up with here is we end up with, okay, here's the fixed boundary over here. We know that this flips over and comes back, so in essence, we know that the square one is here, and the triangular one is here. But those are the outlines. Those aren't actually the wave itself, because the fact that you only have one piece of string. So what happens here is the question. Well, if we count the squares, we know that this is 4 high. So if I just look at these points right here. So this is 4 high, so this is plus 4. This is plus 4. This one's plus 4. This one's plus 4. And this one here is plus 4. They're all plus 4. But if I look at these points right here for this triangular one down here, for example, this one is minus 4. This one is minus 2. This one is minus 2. This one is 0. And this one here is also 0. And so you just add to get whatever the result is. Let me show you what I mean by that. Let's do the middle one because it's easy. This one is plus 4 because it's up 4. This one is minus 4. So you know the result is right there in the middle. This one is plus 4. This one is minus 2. So that's going to be plus 2 because plus 4 minus 2 is plus 2. Same thing over here, plus 4 minus 2. And this one here is plus 4 and 0. So that means that this is the point right here. Same thing over here. And so your waveform actually looks like this. There you go. That's what it looks like when they overlap. So what's it look like after that? Well, now the triangular one continues this way. The square one hits and flips over. And so we have where they're now moving the other direction, and then is there one more? 1, 2, 3. No, that's it. So that's the situation, and it's a little challenging to get this, but what I would suggest is that you outline what each wave looks like, add up the individual pieces, and draw the result. Let's see if we can't do that with the last one also. The last one, though, is the last one is a fixed boundary. So because it's a fixed boundary, it's going to react a little bit different. The waves are still going to bounce off, but when they bounce off, they don't flip. They just stay in the same way. So if I look at this one here, we have a small triangular wave and a small rectangular wave, and they're on their way toward what's called a free end boundary. So in the next picture, everybody has moved. Here's your boundary again. And so the square wave is here. The triangle wave is here. And they're still moving to the right. And what's going to happen this time is, here's your boundary. The square wave is going to stay where it is, and the triangular wave is also going to go in that direction. So if I look at what this looks like, here's the square wave here. Here's the triangle wave here. And then what we need to do is we just need to add them together. It's easy when they're on the same side because one just goes on top of the other. And so what it's going to end up looking like is you have your square wave and then your triangle wave. And that's what that looks like right there. Now we could just as easily have done the points, where this is 0 and 2 gives me 2, and this is 2 and 2 gives me 4, and 2 and 0, and right here this is 1 and 2 gives me 3, and 1 and 2 gives me 3. Works the same way. And then the waves continue, and the square wave is in front, and the triangle wave is behind, and there's your boundary. So there you go. That is the interference worksheet.